Module 1, Wireless Transmission Model, Part 1. Okay. So when we say wireless communication, so we have a variety of kinds that depends on the range and the transmitted power. So we have Bluetooth, Wi-Fi, 3G, 4G, and LoRa. When we say LoRa, it means long range. Okay, so when we already have heard Bluetooth, so we know that it's short range and it can extend up to 10 meters only, and its transmitted power is approximately 2.5 milliwatts. Also, we are very familiar with Wi-Fi or wireless fidelity. Also just short range, but it can extend up to 50 meters. And its transmitted power is approximately 80 milliwatts. Or also cellular or 3G or 4G, it can extend up to 5,000 meters or 5 kilometers. And its transmitted power is approximately 500 milliwatts. And we have our LoRa wireless communication. We can call it low powered one. So it depends on the area where we are trying to apply it. So if it's urban, rural, or line of sight. So its transmitted power is approximately 20 milliwatts. Okay. So if we compare all of this, so we can observe that the lowest or the shortest range is for Bluetooth, and the longest would be for the cellular. And it's directly proportional with the transmitted power also. Wireless transmission model. So common wireless systems for communications include, so number one, terrestrial microwave. So for example, the television transmission. Another will be the satellite microwave. The example is the IP star, and the broadcast radio, so the Wi-Fi, and infrared, so just for in-home communication. So narinig na natin halos lahat nito sa television, sa satellite, so via satellite naririnig natin yan. And of course, the Wi-Fi and infrared. So when we say wireless transmission model, it can be simplified by this illustration. So we have a transmit antenna and the receiver antenna. So in the transmit antenna, we have this is where we send the signal, and for the receiver, this is where we receive. And in between, it is a wireless communication. So this is just a vacuum or air. If we have questions, mamaya na lang after ng presentation natin. So output power. So most of the time, we are looking for or solving for the output power, and it is the amount of power that is received in the receiver antenna. When we say output power, makikita natin yan sa receiver antenna. Okay? So to solve for the output power, we have these parameters. So input power, the antenna gain for transmitter, the antenna gain for the receiver, and also the free space loss. When we say free space loss, we are assuming that it is in the vacuum, and it is we have no obstruction, wala tayong harang, kaya free space loss. Kaya kahit walang harang dyan, nagkakaroon tayo ng loss kasi yung signal natin ay nagsispread out, kaya siya nagkaka-loss. Okay? So to compute for the output power, so we start with the P in or the input power, then multiplied by the gain for the transmitter, gain 1. Then because i-multiply natin siya kasi yung gain, ina-amplify niya yung signal. And also then divide natin ng L kasi yung loss natin, ina-attenuate niya naman yung signal. then multiply again by gain 2 kasi i-amplify nyo na naman. So ganun lang yung formula natin for the output power. So P in times gain 1 divided by loss, then multiplied by gain 2. So kung sisimplify natin yan, so nasa denominator lang si loss kasi naka-divide siya. Okay? So I hope that is clear. So let us try to solve a very simple problem. So we have here some given and let us solve for the output power. So let us first try to examine the units that we are given. So for the P in, we have 100 milliwatts. So yung unit niya is in watts or milliwatts. Then yung antenna gain natin, antenna gain 1 is 10. So mostly yung gain natin will be unitless because it is a ratio. So yung mga gain natin is a ratio. So kaya unitless siya. So 10 lang. For antenna gain 2, 10 lang din. Wala silang unit. And also for the free space loss, 10,000. So wala din siyang unit. Okay? So let us solve for the output power. So P in times gain 1 divided by loss times gain 2, or we can transform the formula like this. Then we will just input this in our calculator. So 100 milliwatts times 10 divided by 10,000. So if we input this in our calculator, makakakuha tayo ng 1 times 10 raised to negative 3 watts, or we can convert this to 1 milliwatts. So very simple lang siya. Okay? So problem number 2 or example number 2, ang mga given natin is input power 10, gain 1, 8. So gain 2 is just 2. Then receiver output power is 4 watts. So ang hinahanap naman dito is yung loss. So using our formula for P out or output power, pwede nating hanapin si loss. So like this, transform lang natin yung formula. And then just substitute the given. So 10 watts for input, then 8 for gain 1, for gain 2 is 2, then all over 4 watts for output power. Then we will have loss of 40. So yung loss natin, wala siyang unit. Unitless siya. Okay. I hope that makes sense to you. Okay. So we have this one, example number 3. So I will try to solve this for you. So let us first examine the given. So we have P in 200 milliwatts and gain 1, 20, loss 500, gain 2, missing, and output power is 100 milliwatts. So let us try to get gain 2. And I already solved this, so I know the answer is 12.5. But let us let me show you how we do it. Okay. Okay. So we have the formula of P out is equal to P in multiplied by gain 1, gain 2, all over loss. So ang given natin is a P out, which is 100 milliwatts. When we say milliwatts, this times 10 raised to negative 3. Then ang P in natin is 200 milliwatts multiplied by, ang gain 1 natin is 20. Then multiplied by gain 2 missing, all over. So loss natin is 500. Okay? So ganun lang. So if we will solve this in a calculator, so ang gain 2 natin is equal to 12.5. May calculator ako dito. Wait lang. $100 exponent negative times 20 times G2 then 500. So 12.5 siya, no? So tama naman ang sagot natin. So kapag gain 2, ang unit natin is wala, unitless siya. So ito yung sagot na. So very simple lang. Okay?